Hello everybody, welcome to the CSS3 course. In this video, I'm going to continue the discussion of grids. So for my last video, I already discussed some properties of grids and the ways you can manipulate your grids on a web page. And in this video, I'm going to continue the discussion with the getters, the grid nesting, the cell overlapping, so on and so forth. So before I discuss these topics, let me show you the HTML file on the left-hand side, which corresponds to the web page on the right-hand side. So in general, the HTML file contains a lot of divisions, and in each of the divisions, you see there are some inner divisions. And for some of the inner divisions, I include the class name. So I'm going to make use of these inner division to create some changes to the conventional grid setup. Okay, that is the end of the HTML file. And I can also show you the web page on the right hand side. So you can see there are so many colored divisions, and the divisions will be treated as the grid cells when it comes to grid setup. Okay. So let me show you the CSS file as well. Okay, so the CSS file mainly contains some of the setups for my web page. So I already included some classes, and I also included some inner classes. So I'm going to change the appearance of the divisions by setting up some properties pertaining to the grid setup. So I can show you the major idea of my CSS file. So I have some containers, and inside the containers I contain the styles for my particular divisions, which are the inner divisions. So the general idea is the same for many of the bigger divisions on my web page. Okay, so for some of the containers, I set up the height and the width of the container so that you can possibly see some color, which is the background color for the particular division. Okay, so you can see the height and the width of the background color again. Okay, so this is the end of the CSS file. So let me go back to the HTML file. Okay, so the first thing to talk about is the grid lines that can be defined by the grid template areas. So remember, a grid layout is simply a two-dimensional layout model. So we are going to set up the grid cells along some columns and along some rows. And how can we make use of the grid template areas to define the grid lines? We can have a demonstration now. So I'm going to set up the grid area name for each of the cells shown here. So now I give the name of grid cell A to be part A, and I'm going to do the same thing for cells B to F except G, which is the one that I'm going to change later. Okay, so how about the container that contains these grid cells? Let me show you the way to set the grids here. So now I've changed the container to be in the form of the grid display mode. Now I want to set up 5 columns for the grid display, and each column has one fraction of the viewport width. Then I'm going to set up the grid template areas by using the grid area names. So I completed one row. Then I also completed another row. So I also completed the third row, and I have one more row. Now I have already set up 4 rows, and you can now see that the first row contains grid cell A, and grid cell B is placed on the top right hand corner of the entire containers. So let me show you the form a bit more clearly. So the first 3 portion goes to cell A, and then part B is the top right hand corner, and part C is placed below grid cell A, which occupies 4 parts, and part D has 1 portion shown here, and part E has 3 portions shown underneath grid cell D, and part F has occupied an entire row. But how about grid cell G? Since I haven't put grid cell G into the grid template areas setup, it is just placed according to the auto placement rule of the grid cells. So here, the grid cell G is treated as unhandled by the previous set of code. So if I want to do some treatment on grid cell G, I can have some idea by using the grid lines defined by the grid template areas. Now you can see that when I set up the grid row property as part D start and part E end, I just go back to the grid template areas. So part D start refers to the grid line that helps me to start the grid cell D. Okay, so this particular horizontal grid line becomes the part D start grid line. And part E end refers to this particular horizontal grid line. So you can see that grid cell G is contained horizontally by the particular horizontal grid line called part D start and the horizontal grid line called part E end. So this part is given by the grid template area names, and this part called start or this part called end is simply suffixed to the grid area names. Okay, so we can make use of the grid area names to define the grid lines. So we can do similar things for the column grid lines that help me include grid cell G. Okay, I changed the color of grid cell G to red. So the grid column attribute has a value like this: part D start / part D end. So what does it mean by this one? When we go back to the grid template areas, we just make the starting column of grid cell G to be this particular grid line. So this part is the beginning of part D, and the grid column wants to end grid cell G before the grid line called part D end. So when we check part D, we have only this portion to be part D. So part D end refers to this vertical grid line. So you can see that grid cell G has the horizontal grid lines defined before and the vertical grid lines defined by using the grid column attribute. Okay, so we just refer to the grid area templates set up to see the definition of the grid lines that end with start or end words. Okay. Then I'm going to talk about another topic called getters. So we don't always need to pack up all the grid cells so tightly. Instead, we can give some separation between the grid cells. So how can we do that? We can take a look at this example.
So let me set the display mode first.
Now I set up the display mode to be grid, and then I set up the grid template columns to be a repeat function that has one fraction to be repeated for 3 times. So you see there are 3 columns, each of which has the same size. Okay. Now I can try to set up some gaps between the cells. So how can I do that? I can make use of the idea as follows. Now I set up the grid column gap attribute to have a feather of 10 pixels. So you can see that the grid cells are separated by 10 pixels of some gap, okay? And I can have some similar settings for the horizontal gap. Now you can see that the gaps are set up horizontally to be 20 pixels. So you see the horizontal gaps are wider than the column gaps. In addition to using 2 separate attributes to set up the getters, we can have a shorthand form as follows. So if I set up the grid gap attribute as 20 pixels and 10 pixels, it just means that I want to set up the grid row gap attribute to be having a value of 20 pixels, and then for the second value here, I just want to set up the grid column gap value to be 10 pixels. So we have this order when I use the grid gap attribute. The row gap followed by the column gap. So after setting up the gaps, the remaining dimensions will be calculated automatically after deducting the gaps. So when I enlarge the screen, you can see that the gaps will still be maintained to be 20 pixels and 10 pixels respectively, but the grid cell width will be changed accordingly by the deduction of the column gaps. And then after deducting the column gaps, the column widths will be calculated accordingly. Same for the horizontal gaps that make the grid cells a bit separated vertically. The next topic is about the grid nesting. So when we check the HTML file, you see that I have a certain division that contains 2 more inner divisions. So these inner divisions are going to be called grid cell B1 and grid cell B2. So initially I could just say that the entire division is simply grid cell B, rather than having 2 more inner divisions. So how can we handle the nesting property? We can take a look at the CSS file. So for now, all the cells are aligned according to the markup order. So now let me set up the nested grids. For now, you can see that grid cells B1 and B2 are contained together, because you can see on the HTML file that these 2 inner divisions are contained inside the outer division whose class name is called nesting-box. Okay. So you can also see that grid cells A, C, D, E, and F are placed quite naturally according to the auto placement rule. So for now, grid cells B1 and B2 are placed with B1 on top of B2. So let me try to change the settings of the inner divisions now. I forgot to delete the division tag here, because I just want to set up another inner grid. I need just the container class that is called nesting-box. I don't need to care about the divisions contained by the container class. In this container, I still set up the display mode to be grid. So you can set up the inner grids as follows. So I repeat 2 fractions inside this particular nested grid, and you can see that the outer cell getters are not inherited to the inner grids. So you can see that grid cells B1 and B2 are joined together without setting up the getters. So you can see the meaning here. The getters outside the nested grid are not inherited to the inner grid. Okay. Then the next topic is about overlapping cells. So what does it mean by that? We can have a look at the example shown here. Okay, so now let me set up something here. I have set up the grids first. So now I have 3 columns of the grid. And now I'm going to set up the position of grid cell A with the styles shown here. So now you can see that grid cell A has spanned a lot of space. And after setting up the position of grid cell A, you can see that the positions of other grid cells will be placed according to the auto placement rule, from left to right and then from top to bottom. This is the default style for English language. And now let me try to position cell F a bit differently. Okay, now you can see that grid cell F is able to hide the entire grid cell A. Why? Because the cell F settings are placed after the cell A settings. So by the cascading property of CSS language, the later part will prevail. So in this case, cell F is simply hiding cell A. So how about making A float on top? We can have a method called setIndex. So in general, setIndex is set by default to be 0. So if we want to make your element to be on top of many other elements, you can set your setIndex to be something larger than 0. So if I set the setIndex to be 3 for cell A, you can see that cell A is able to come back again. So originally it was hidden entirely by grid cell F. But when I change the setIndex of cell A to be a value larger than that of cell F, you can see that cell A can come out. So now it just implies that cell F has a setIndex of 0. So when I set the setIndex to be 0 for cell F, the effect isn't changed. Okay. The next topic to talk about is the cell alignment. So let me go to the corresponding HTML file and the corresponding CSS file. Now I want to set up some grids on this container first. So this example shows you the default way to place these cells in a certain container. So when I set up the column width to be 150 pixels for the first column and 100 pixels for the second column, you can see that I have only 2 columns to be shown, and the columns are put to the left of the container. So A and B are packed tightly to the far left of the container. And for the grid rows, it has the similar idea. So 40 pixels for the first row, 60 pixels for the second row, 30 pixels for the third row, and 50 pixels for the fourth row. And you can see that these rows are packed close to the top of the container. So you can see that the default alignment of the cells are quite natural by trying the best to go to the top left-hand corner of the container. In fact, we can change the alignment format by setting up some more properties. So let me go to the other part called More About Cell Alignment. Okay, before I discuss the cell alignment issue, I have to discuss 2 more terms, which are called the block axis and the inline axis. So the block axis is the direction of the block layout, which depends on the writing mode. So when you look at the web page, you can see that grid cells A would be on top of grid cell B, which is on top of grid cell C, and so on and so forth. So this is called the block layout order, which is simply following the HTML markup order, okay? And when we have such a block layout mode, we can say that the block axis is simply the vertical axis, because the block axis is simply the direction of the block layout, and you can see that the vertical direction is the block layout direction. And we have one more term to consider, which is called inline axis. The inline axis is simply perpendicular to the block axis. So when I have already defined the block axis, the inline axis is defined immediately. So in this case, for English language, which is a left to right language, you can see that the inline axis is simply the horizontal axis. Okay. So when we talk about the writing mode, we have some formats. One format is called horizontal top to bottom, which is the mode for English language. So if we try other modes like vertical right to left or vertical left to right, the block layout will be different. So when I say vertical right to left as the writing mode value, now you can see that the block axis is a horizontal line from left to right. Okay, and of course the inline axis is perpendicular to the block axis, which is simply the vertical line direction. Okay. So how about another writing mode called vertical left to right? Now in this case, the block display mode is from left to right horizontally. So a horizontal line from left to right becomes the block axis, while the inner axis is the vertical line. Okay. So let me change back to the horizontal table to bottom mode, which is the default mode actually. And after we have known the writing mode, we can learn more about the alignment of the cells. So let me set up the grids first before I discuss more about this issue. Now I set up 3 columns explicitly with some predefined widths. And now I also set up the grid auto rows attribute to be 50 pixels. So it implies that the implicit grid dimension has a size of 50 pixels. Okay. So you can see each row has a size of 50 pixels. So let me try to change the alignment mode. I can have one idea by use of the keyword called align items. Okay, the align items attribute is helping me to change the alignment format. So when I use start, it just means that the items along the block axis is changed to another mode called start. So when you see the diagram here, you can see that the block axis is simply the horizontal axis that I showed you previously. And the attribute called align items helps me to align the items along the block axis a bit differently than before. The default value is called stretch. So I just span the entire block axis dimension to show the items. But when I just use start, you see the cell height is just changed to the height determined by the text content. Okay. So we have to notice that when we use the word align here, it just means that we want to align along the block axis in some mode. Okay. So for now I use start. How about changing it to other values? Okay, if I use end as the align items value, you can see that the cells are put close to the end of the implicit grid dimension. Okay, so as opposed to the start value that puts the cells to be on top, the end keyword puts the cells at the bottom of each row. Okay, how about center? When I use center, the grid cells are placed in the center of each implicit grid row, okay? So let me try to introduce another attribute to you called justify items. Okay, when I use the justify items attribute, you can see that I can align the cells along the inner axis a bit differently. So remember, the inner axis is simply the horizontal direction according to the block mode order, okay? So the word justify here means that I want to align the cells along the inner axis a bit differently. So of course, the default value of the justify items attribute is still stretch. But when I change it to center, you can see that the grid cells don't span the entire possible width. It just takes the enough space determined by the text content, okay, and then it does the centering alignment along the inner axis, which is the horizontal axis in this case. So rather than using these two attributes explicitly, I can have a shorthand form. Okay, the shorthand form is simply following this order. We put the value for the align items attribute, and then we put the value for the justify items attribute. So now align items becomes end, and justify items becomes center. So that's why you can see the change in the cell alignment. For the block axis, the cells are placed close to the end of each implicit grid row. And for the center keyword here, it just means that the items are placed in the center of each grid cell, and the width is determined solely by the text size, okay? Okay, in addition to setting the alignments inside the container, we can still change the alignment of individual cells. How can we do that? We can make use of similar ideas but with a bit different keywords. So let me go to cell A here. I don't want to follow the general idea coming from the container. I want to set grid A a bit differently from others. How can I do that? Let me show it now. Okay, I used justify-self attribute to help me change the position of cell A a bit differently. So I use start as the value. Now you can see that grid cell A is a bit closer to the far left of the container. Why? Because I just placed grid cell A to be the starting position of its grid along the inner axis, which is the horizontal axis in this case, okay? So the word justify here means that we want to align the cell along the inner axis a bit differently. Again, the default value is stretch. So you see the entire grid cell is occupied. So let me change to start again. So you see the grid cell is just put next to the far left of the container. Let me change the position of grid cell B. I use align-self attribute for cell B, and I put it to be center. So you can see that grid cell B is a bit pushed up because I want to put it to the center of the original grid for cell B. So I can use align-self attribute to help me do so. Of course, we also make use of the shorthand form to specify these two attribute value pairs in one row. So let me go to cell D, which is this one. Okay, for cell D, I can set the align self property first with stretch, and then I set up the justify self attribute to be center. So one line is able to specify two properties, okay? So now you'll see that grid cell D is stretched along the block axis, and it is placed in the center of its original block position. And the center position is determined by the length of the text, okay? We can also simply specify the track alignment. So how can we do that? We can take a look at the example here. Now for this example, you can see that I didn't hide all the container background. Why? Because I already set up the height and the width of each cell to be some fixed size. Why? Because I set up the container background to be some fixed size. And you see the height of the text is a bit limited, so that when I just have 6 divisions, the height of the text is not able to cover the entire container size, okay? So now let me try to set up the grids for these 6 elements. Okay, now I already set up the columns and the rows for the grids. Okay, so you see there is a lot of space after setting up the columns and rows for my grid layout. So how can I make use of the grid track alignment techniques? I can do something like this here. Now I can make use of the align content attribute to help me align the cells along the block axis a bit differently. So I use center here, and then you can see that the blocks are put in the middle of the height of the container. Okay, so I can do similar things along the inner axis. Okay, I use justify-content attribute, and then the value of it is space hyphen between. So you can see that there is some space between the 2 columns, and now the right hand column is put to the far right of the container, and there is some space between the 2 columns. Okay, so that's the meaning of space between. So when you want to align the grid track along the block axis a bit differently, you can use the align content attribute. On the other hand, if you want to align the grid tracks along the inner axis, you can make use of the justify content attribute. Okay, I can also make some changes to grid cell A in particular. How can I do that? Let me go to the CSS file first. Now you can see that I can change the appearance of individual cell even though I set up the grid track alignment on the container. So I can use margin-bottom attribute to set up the margin for a particular grid cell. So when I use auto, the margin is calculated automatically according to the height of your text or your content in general. So you see the text is not that high, so you can see some margins can be produced. So that is the way to set up the margins even though you set up the grid track as a whole. Okay. The final topic to talk about is the absolute positioning of grid cells. So let me check this web page here. So for the CSS file, I have set up a container of some height and width, and I want to change the display mode to grid first. So now I have 6 grid cells to be shown. Now I set up 2 columns and 3 rows of particular sizes of the columns and the rows. Suppose I want to change the position of grid cell A, so I just want it to be a bit different by deviating from the setup on the container. So how can I do that? I can make use of the keyword here. I want the elements inside this container to have some different positioning property. So I can set the position property first here. I set position to be relative. So what does it mean by this attribute value pair? It says that the child elements can be absolutely placed relative to the container. So now I set the container to be relative, and after that I can simply change the position of a particular cell absolutely, which is still relative to the container itself. So let me do something now. Now I change the color of grid cell A first, and then I want to change the position of grid cell A so that it deviates from the settings given by the entire container. So now you can see that grid cell A is actually removed from the conventional setup of the grids. So I have to set the position of cell A to be absolute. Then I set up the top value and the left value for cell A, so that grid cell A is a bit separated from the top of the container and from the left of the container. And after removing grid cell A from the conventional grid setup, you can see that grid cells B, C, D, and F would follow the auto placement mode. So grid cell B is put on the top left hand corner, and grid cell C is put on the right hand side of cell B, and then D is put below B, which starts on another row, so on and so forth. Okay, so by means of the combination of the position being relative for the container and position being absolute for the particular cell, you can simply remove the particular cell from the conventional grid setup, and you can simply place the cells relative to the given container in some absolute sense, measured from the container. Okay. So this video has already talked about many more types of operations on grids. For example, you can make some grid lines according to your grid template areas, and you can also set up some gutters, and you can even nest your grids inside the inner division, and you can do the overlapping of cells, and you can align the cells a bit differently from the conventional setup, and you can even align the entire grid track. Even more, you can put the grid cells out of the conventional arrangement of the grid cell layout. This is the end of the video. If you have any questions about my video, please leave your questions on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.